All right, we are going to start off by taking some notes on the three different types of chemical bonds. So you should have your note sheet that looks like this in front of you, and we'll define and discuss the properties of the three types of chemical bonds. But before we do that, I'd like you to flip over your sheet to the blank side so that we can first define what a chemical bond is. Okay, so first of all, we're going to talk about what is a chemical bond. Okay, so a chemical bond is an attractive force between two atoms. So it's an attractive force between two atoms. And when a chemical bond forms, the atoms either share or transfer electrons. So it's the sharing or transferring of electrons. Okay, and why does this happen? Well, it really comes down to the octet rule. Remember when we were learning about ions, we said that atoms will gain, lose, or share electrons to get a full valence shell. And what a full valence shell is 8 valence electrons. Okay, and so really a chemical bond involve just the valence electrons. And it's all about getting that full valence shell because this gives them a stable electron structure. And that's the whole point of this octet rule, is so that they find stability. All right. Okay, so I'd like you to flip over to this side of your notes sheet now. We're going to start off by discussing ionic bonds. So we're going to start over here with ionic. Okay, so I'm going to zoom in and we'll go ahead and define ionic bonds. Okay, so an ionic bond is an electrical attraction between a positively charged ion and a negatively charged ion. So it's an electrical attraction between a positively charged ion and a negatively charged ion. Okay, so it's an electrical attraction between a positively charged ion and a negatively charged ion. Typically, it is between a metal and a non-metal. Okay, so it's a metal and a non-metal. The metal being the positively charged ion and the non-metal being the negatively charged ion. Okay, all right, so the positively charged ion, this is called a cation, and again, this is typically the metal. Okay, and what happens when a cation is formed is it has more protons, which are positively charged, than it does electrons, which are negatively charged. Okay, and the atom itself loses electrons and becomes positively charged. So the atom loses electrons and becomes positively charged. Now the negatively charged ion is called an anion. Whoops. It's called an anion. That's the negatively charged ion. And remember, this is typically the nonmetal. Okay, and anions, being negatively charged, have more electrons, which are negatively charged, than protons, which are positively charged. And what happens is the atom steals electrons to become negatively charged. Okay. So that's how an ionic compound is formed, is a cation or two atoms, a metal and a nonmetal, come close to each other. So this metal and nonmetal come close to each other. And what happens is the nonmetal steals electrons from the metal. And this causes the electrons to kind of be transferred from the metal to the nonmetal. When an ionic bond is created between two atoms, it creates an ionic compound. And ionic compounds have specific properties. So we're going to discuss some of those properties. So ionic compounds have high melting points and high boiling points. They also are solids at room temperature, and they dissolve in water. Ionic compounds conduct electricity, and they're very brittle. These are some of the properties of ionic compounds that make them stand out aside from the other two types of compounds that we're going to learn about. Now, when an ionic compound forms, again, we have a metal and a nonmetal. So sodium here is a metal, and then we have a nonmetal like chlorine. Now, sodium has one valence electron. I'm going to use the Lewis dot structure to represent the valence shell. Remember that underneath this valence shell, there's also a full electron structure. But sodium has one valence electron and chlorine has 7. Okay, so this is what the valence shells of these two atoms, a metal and a nonmetal, look like. Now, when these two atoms come close to each other, what's going to happen is chlorine is actually going to steal sodium's valence electron. Okay, and it's going to come over here. Now, when chlorine steals sodium valence electron, sodium is now happy. It's ready to give away that electron because it has a full valence shell, and chlorine is going to steal it to complete its outer valence shell as well. Now, when sodium loses an electron, it now has more protons, so it becomes positively charged, and chlorine has stolen an electron, so it is now negatively charged. We know that opposites, I spelled opposite wrong. Opposite? Okay. All right, we know that opposites attract. And so the positive and the negative charge of Na and Cl, so the positive charge of sodium and the negative charge of chlorine form this attractive bond between them.